Hello, everyone, and welcome to our first webinar in the series where we will explore how to make better motor design decisions earlier. But let me introduce myself first. My name is Lisa Sitar. I'm a marketing officer at Infinite Simulation Systems and a moderator of this event. Before we start, I would just like to quickly show you some instructions and share some important information with you. So first of all, please know that this webinar is being recorded and you will receive the recording afterward. Secondly, you cannot unmute yourself, but however, I would really like to encourage everyone to still ask questions, and you can do so by typing the question under the Q&A section. You can also see on your screen, and all the answers will be provided together with the recording after the webinar. So today I'm joined by my colleague Nima, who will start with a very short introduction of our company. And afterwards, you will hear from our application engineer, Shashank, who will tell you more about Motor-CAD and its role in speeding up multiphysics design workflows. So Nima, the word is yours.
Hi, everybody. Okay, a brief introduction about myself. My name is Nima. I'm an account manager with Infinite, specialized in optics, photonics, and electromagnetics. I'm glad to be here today with you guys, and I'm going to do a little bit of introduction about our, let's say, company. So, Infinite is a lead channel partner of Ansys in the Benelux region. As you can see, we have two different locations, one in Breda, one in Leuven in Belgium. And we have the honor to serve a lot of customers, to be honest, and a lot of student members, a lot of startups. And this is always nice to see these booming, let's say, companies, engineers, enthusiastic people. Uh, for today, we are focusing on Motor-CAD. That's a part of electronics package of Ansys. And I'm going to dive a little bit more into why we're going to use Motor-CAD and, who is it useful for? So, first off, I would say that in the past, it was very different. Now it has evolved from a single physic like EMAG it used to be to a multi-physics. Why I mention multi-physics for AutoCAD today? It's because that today you can do thermal analysis and noise and vibration analysis also in a MotorCAD. Of course, limited, but still. And there is a good combination between MotoCAD and other ANSYS solutions like ANSYS Mechanical and, of course, Maxwell for deeper simulations and analysis. Well, there are many different ways to say it, why the need for MotorCAD today, and a lot of different aspects that engineers would tackle. There are a couple of things which stands out most of the time. Well, when we're talking about electric motors, the designs for many different purposes can be e-bike, can be pumps, compressors, and all those let's say designs. You would want to know the capacity of your electromotor, optimize it, and make changes where needed. When it's about thermal modeling, yeah, of course, the winding temperature is very important and the cooling strategies. So the cooling strategies is one of the factors like in capacitors and a lot of electric components you would want to discover if it's the best if you go with the air, liquid, or oil cooling. With simulation, you can easily, let's say, understand which one is economically and engineeringly the best option. When it comes to different performances of the, let's say, a motor, it is also very important to see what is the maximum capacity that you can push for, and let's say where the failures taking place. This is particularly interesting for the companies where they have like guarantees and warranties. They would like to see what is the maximum level and the performance. uh, as I mentioned earlier, this multi-physics coupling also helps out with many different aspects like vibration and some sensitive, let's say, small electromotors. Vibration can be very important, or thermal analysis if a failure is going to happen, if it gets overheat, or any other, let's say, physical aspect, the aspect of this motors. You can do that. And of course, design optimization, less material, lighter, which is always a reason to go for simulation. Here, I will hand over this webinar to my colleague, and he will be explaining more in depth. Thank you.
Thank you, Nima. Yes, I think you all should be able to see my screen and hear me clearly. So my name is Shashank Shanbag. I am an application engineer here at Infinite Simulation Systems, and I work mainly with the electromagnetic solutions that we provide. That's MotorCAD and Maxwell. Both of these are electric motor design tools, but today we are going to talk more about Ansys Motor-CAD specifically, and I hope everyone can get some idea on how they can leverage MotorCAD in their design process after this webinar. And you can also look at the possibility of how different parameters are chosen within MotorCAD, how you can do an extensive design exploration of your desired motor. So let's just dive straight into it. So, as Nima previously explained, the need for MotorCAD. MotorCAD is a template-based design. So, in all those applications that he mentioned, you can easily start with a template that's provided for you, and you do not have to start from scratch. You do not have to uh, draw each intricate model individually. You have some set of parameters already ready for you. You can tweak those parameters, customize them however you want. You can work with them easily. And within MotorCAD, you have different machine types. So as you can see, I've listed some of them. You have a lot of options, and you can, I think, possibly design any kind of motor that's already existing, or you can create your own design as well with the custom options. And within the brushless permanent magnet, we have also recently introduced the axial flux motors, which are the hot topic in industry right now. And it's really nice to work with that in MotorCAD, because then you have a set of guidelines which I'll show you further. Um, and there is automated winding definition within MotorCAD, so you do not have to think much about what kind of winding you have to do, and do you want to design those one by one. No, you can just see the preset templates. You can customize it based on your required um, motor design, let's say. And you can always import custom geometries as well as DXF import files. You can bring them in. You can match them with the templates that are existing in the motor. You can change the parameters and see how they perform. So motor design workflow. So here you can see the rough workflow that you will be using, and this will guide you through the whole motor design procedure. And by that I mean that you start with a geometry setup of the model. This is how you usually start, and then you go on to the winding assignment, the material assignments, and once you have done these things, you go to the electromagnetic simulations, and you see the performance of the machine, how it's behaving, and then after checking the performance, you see some differences, or you go back and tweak some parameters. Then you can either go to the thermal module, you can check for the cooling system, how you want to implement it in your motor. You can do the stress analysis, all within MotorCAD. You can go to the lab module. So I'll explain about the specific lab module later, but it's a brief way for you to do some experimental scenarios on the tool itself. You can check for how the machine would perform. And finally, you can also do the NVH analysis. You can check for the different vibrations, how the sound from the motor is. Yeah. And once you follow this workflow, it will be really easy for you to have a complete multiphysics design, and you'll be ready to go with your motor. So let's start with the geometry. So here you can see the GUI of MotorCAD. So there are different motor types available and the different modules available all within the same interface. You do not have to go to a different tool to do, let's say, a mechanical analysis. And if you want to do a thermal analysis, you do not have to go out of this interface. This is all within the same MotorCAD, and you can just go one by one, like the steps that I just mentioned earlier. And here you can use the check button to see whether the geometry that you're working with is valid or not. And the user can select template geometry that's defined in terms of dimensions, or you can either do like a ratio based parameterization. There are set of ratios that you can apply to, let's say, scale your machine or do some kind of optimizations. And you can use adaptive templates also to generate your own designs using Python. And this is all again within the MotorCAD interface, and you can check for the different geometry templates. You can check, we easily set up new design to match that of an existing one. And there are options to include the customization as well, according to the adaptive templates. And you can bring in a different DXF model, and you can just parameterize it here. So once you have the geometry ready, what do you do next? You go to the windings and materials. So Ansys Motor-CAD contains a tool for automatic pattern creation and conductor placement. So this means that there is feasible windings that can be quickly assigned and compared, and options for creating custom patterns are available here. And the visual editor here that you can see gives you various options to select different wire winding input parameters, wire selections, and you can update the winding layers, the path type that you want to apply, observe the radial and the linear patterns of how the windings would look. And you can also visualize the different coil loops and see the phasors. You can also visualize the magnetomotive force, the harmonics, and these can be visualized in terms of mechanical or electrical frequency. And we can also see the fundamental winding factor as it directly is proportional to the torque of the machine. So you can do that as well. And here in the material assignment, you can see that MotorCAD gives you a built-in library of database. So you can either use the database that's existing here, or you can import your own material. You can bring in those values and you can assign those here. And you can check the overall weight of the machine after assigning these materials and see whether it's sufficing, let's say, your manufacturing needs. And you can follow different magnetic properties of the machine, of the magnets. Let's say here you can check for the BH curve, you can check the demagnetization curves of the magnets, etc. And once you have set all these, you then go to the e-magnetic module, the first one that you would go to. And in the electromagnetic module, you have a combined 2D transient FEA and an analytical method for motors. So this means that you do not have a complete 3D model, but you have a 2D FEA that's analyzed and extrapolated to the actual length that you would define for the motor. And you do not have to worry much about the setup because it's automatically setting the meshing and the boundary conditions. And of course, you can tweak these parameters according to your requirements if you want some detailed points that you want to mesh and the regions that you want to look specifically. And you can check for eddy currents in the magnets, induction motor rotor bars. You can check for iron losses, AC winding losses. And the best thing is that you have a coupled solution with the thermal module available here. So you can see the electromagnetic performance and then take that into the thermal module and see how the machine would behave. And by the end of this, it rapidly calculates the electrical and electromagnetic performance. It gives you the answers really quickly because it's a 2D transient FEA and an analytical method that's being used here. And this enables the engineers to quickly test various parameters for their design exploration. So you start off with a rough design, and then you narrow it down to like a specific design. And here you can see the e-magnetic module. So starting off with some templates that's available already for you on MotorCAD, and you can see that the motors can be analyzed against specifications, and you can obtain torque and the back EMF for important operating conditions. And also there is the distribution of flux density in the machine that can be monitored within this e-magnetic module. You can see that the MotorCAD e-magnetic module provides methods for calculating the susceptibility of motor to irreversible demagnetization, for example, which can be a huge issue. And you can see how this demagnetization may affect the overall performance as well at the same time. And you see there are various output data that are available after you're solving the magnetic module. You can see how the phases are. You can see how the equivalent circuit would look like. You can see different losses generated due to this electromagnetic behavior. And of course you'd like to see the graphical view of these parameters. So you have already set graphical parameters, but you can also create your own custom graphic settings and monitor them. And finally, there is also sensitivity analysis available. And just before that, you can see here the one of the slices of the motor being analyzed, and you can see the result of the flux density, vector potentials, current density, and you can see different regions. And for the sensitivity analysis, you can change different parameters. Like you can see here, you can change the phase advance angle, you can change the voltage, you can change the line current, shaft speed, etc. And you can check for how it would behave in different scenarios. So once you do that, the next thing is the lab module. This is one of the best parts of MotorCAD, I would say, because lab module provides you a nice way to experiment with the machine. And you can, like for example, here you can analyze inverter driven motors, and you can check for range of operating conditions, how the machine behaves. It uses FEA and the analytical Emacs solvers to build the loss maps, and also different parameter performance maps that you can generate within the lab module, which I'll show you later as well. And this easily couples with the thermal solver as well as the electromagnetic solver. So you have both of them working together, and you can see the combined behavior in your motor, and you can plot them as you go. So it also applies the maximum torque ampere control strategies to replicate the performance of the motor. So like I can show you here, you can see the efficiency maps, and you can see different motor and generator regions. You can see peak torques and speed curves. You can see continuous torque speed curves. You can do the duty cycle analysis. And like I said, you can do open and short circuit tests, just like you would do in an experimental setup. And how you do that would be in the lab module. So you go to the lab module, and then you have different model build options. You can set up the saturation parameters, which kind of model you would like to use, how refined you want this to be. And once you set these parameters, you can easily create efficiency maps, plot torque, speed characteristics, and you can study the continuous and peak constrained operational envelopes and analyze the performance over different driving cycles. So let's say you do electromagnetic analysis here, you can check for the performance. It'll show up in a minute. So here you can see the shaft torque versus speed, and once you have these, you can also check at different, let's say, drive cycles, or based on what kind of experiment you would like to work on, depending on your situation. You get different plots, already existing plots. You can create your own plots here within the lab module, again, like I mentioned earlier, and you can set the parameters that you would like to observe. There are various duty cycle operations, so there are already like automotive drive cycles available within MotorCAD. You can choose those and see how your motor would behave in these different drive cycles. You can see the parameters of, let's say, shaft. You can see the speed. You can see efficiencies. You can check all of these together at once. Here, how each of them behave throughout the drive cycle, and based on what you see, you can go back to the electromagnetic or the thermal module. You can tweak the designs and you can see the behavior again. So it's like an iterative way of working, a really nice way, because this is an early phase design tool, so you can check all of these parameters already in your design phase early on, and not have to wait until the prototype is ready. And this is the here one of the options in lab module is that you can set operating points. So let's say you want to see the torque at 250 Newton meters of your machine, how different parameters are behaving. You just set the parameter and then you calculate the operating point. Then that will give you a value. Let's say the phase advance is 34.48 here. You go back to electromagnetic module, you see that's already been updated there, and at that particular value you will check what kind of an electromagnetic uh, behavior is available, and then you can, if it's working perfectly for you, then that's great. Otherwise you can tweak those again within the lab module and or the electromagnetic module. And so there are these all these options available for you within. You can check for the test as well, like the open circuit and the short circuit test, like I mentioned before. And once you do this, you can either move on to the mechanical module, or you can go to the thermal module. But let's say if you move to the mechanical module, you would first look at the rotor stresses based on, so here it's FEA based stress analysis. So you can check for the von Mises stress in the rotor. So let's say previously you would do an electromagnetic simulation and you had to wait to move to a mechanical simulation software tool to see how the motor would behave in different stress conditions. But in MotorCAD, you do not have to wait for that. You can just bring it into the mechanical module and you can see the performance. And the other option here is also, like I said earlier, the NVH. So you can check for different vibrations. You can see how much noise your motor is producing, how you can reduce the noise, and various factors like that. So in the mechanical module here, you can check the different rotor stresses. So let's say I move ahead here, and you can see the model, the mechanical module. You have different properties available. The database for the materials are also available. You can check for the Young's modulus, the uh, parameters, and you can set them. And once you solve for the rotor stress model, you receive a plot where you can check for different regions where the stress is high. So here, let's say you move on to particular regions and you can see where the stress is high, and you can make changes accordingly. And the mechanical FEA assumes a 2D plane stress, and the stress in the actual direction is assumed to be 0 here. So that's what you need to know. And once you do this, you can go to the thermal module. And the thermal module for MotorCAD, it's an industry standard tool. So it's been built over 25 years, and there is influence of CFD, FEA, and empirical correlations based on the experimental data that has been correlated to get these models. And this generates a thermal and flow network automatically. So you can see the thermal network, and you can visualize different regions of the motor, how the flow would be. And so mainly it's to see the heat transfer paths, to see how you can improve the heat transfer and make effective use of your motor in a system. And you can do different iterations, and you can explore the whole design space that you have alongside the electromagnetic analysis, and you can ensure that you have an optimal design. And in thermal module, you have various cooling options. So there are lots of options here. You can see, you can employ any one of these or check with all of these based on your design requirements. you can visualize how the heat dissipation can be used effectively in your system. So coming to the thermal module, here is the visual. You have a way to set different parameters like the ratio-based parameterization, like I mentioned earlier. Here you can see how the motor would look like. Just going forward, you can visualize the fluid flow as well in the direction, which direction you would like it to flow. You can also have it inside the shaft or outside in the housing, and you can change these parameters accordingly. How much spray cooling, let's say, you want on the end winding, and all of these options can be set one by one. I'll just quickly move ahead here, and here you can see different interfaces that are available within the motor. So let's say from stator lamination to housing, from housing to the overhang of the end winding. And so you can set each of these parameters one by one. You can see what kind of material is used. You can see the thermal conductivity, and you can set the resistances of each of these interfaces. And based on these interfaces, you will later be able to solve and check for the lumped circuit model. So here you can see the steady state model, the thermal model here, and the next you can also see the lumped circuit model in detail. So you can see at each point what kind of temperature is generated. You can visualize it easily, see where are the hotspots, where are the regions which you need to consider to change something, or if everything is perfect for you, you can check all of these. And there is also a lot of options to do sensitivity analysis within the thermal module. You can run different parameters, so you can set different parameter in steps, and you can check for each step how much the temperature is, which is the best option for you to go ahead with. So let's say here I go ahead, and here you can see at different stator lamination housing temperatures. So you get a range of values. You can choose which value suits best for your uh, application. And again, duty cycle analysis is also available in the thermal module. So you can set a duty cycle and see the temperature, how it would behave. And at the end, once you do all these, you can check for the temperatures within the rotor and the stator. So let's say you see at different areas what kind of temperature is generated based on these values that you have set, and you can make a decision accordingly. So we saw that all of these physics work together really smoothly in Motor-CAD. There is the EMAG module, there is the mechanical lab, and the thermal module. So based on what kind of design choice you want to make, you can move within these modules easily one by one. It's very easy to go from one to the other. You can the values are updated automatically, so you do not have to change these values in a different physics as well. So as you can work with each of these easily, it brings the complete multiphysics design really easily and rapidly. And the important part is its accuracy. So these models are tested with experimental data, and they are compared, and these give really accurate results. But finally, coming to the key takeaways here. So when starting an electric machine design, you always start with a large design space and then narrow it down to the specifics based on your requirements. So it's an iterative process, and considering geometry parameters, you set the winding configurations, material data, and the multiphysics performance output of the machine is obtained. And once these are done, you can later go for optimization strategies with OptiSlang, let's say, or moving into Fluent for some more detailed CFD analysis. And it might seem like a lot of information here, but you can also always reach out to us in case of any queries, and we'll be happy to help you. And that's it from my side. Thank you very much. Over to you, Tisa.
Yes, thank you, Shashank. So thank you everyone for joining. I hope you enjoy this short session. But before we say goodbye, I would like to invite you to join us for the second webinar in this Motor-CAD series, which is also our last webinar. Here we will dive even deeper and talk about the need for system engineering approach when designing a motor, and also introducing you to the functional mockup interface, which is available in Motor-CAD for this particular purpose. So please, if you scan the QR code, you can register, and I hope I will see you next time. So thank you once again, and I wish you a great day ahead.